أستاذة هند.
ايوه.
هلا بالنسبة أنا متأخرة صراحة في المحاضرات عشان إنه بالعافية لما تنزل عندي تاخد وقت، لما ينزل يوصل نص التحميل بقطع.
Hello. Hi, everyone. Welcome to today's session. We'll be waiting for the rest of the trainees before starting, so let's take a few minutes to get everyone on the call. So, can everyone hear me and see my screen? Good. We're only 9 people in the session right now, so let's give the rest of the trainees a couple minutes to finish joining, maybe. And then we'll start. Well, I think we will start with today's session now, and the rest of the trainees will join as time goes on. So, hello everyone, and welcome to today's session and the first Node.js and server code lesson. This is going to be the first part of this training course. We will have a few other parts follow in the following weeks, and you should, by the end of it, be able to develop a backend to communicate with basically front-end applications you've been building up to now. So what will we see in this course? We will discuss quickly what Node is and what is V8 in relationship to Node. We'll talk quickly about the Node CLI, how we execute files with Node. We're going to talk about Node modules, exports, requires, and all these concepts. We're going to quickly go through callbacks and promises and a few important Node core libraries. Basically, we're going to go through events and reading data from the file system. For development purposes, we are going to see how we can watch live file changes so we don't have to basically keep executing our files as we develop. We're going to see how we can create a web server with built-in HTTP library in Node, and then we'll explore the Express framework. We're going to create a web server, and then we'll be writing our rights controllers to basically fulfill the need for a whole API. And we'll check useful libraries to use with Express, so our API is full and functioning well. We'll take a look as well at cron jobs, which are basically time conditioned jobs, functions that you want to run at certain times of the day. They are called workers, basically. We'll see them in more detail as we reach the end of the course. So what is Node exactly, and what is V8? You already have a few some understanding of Node, I believe, through NPM and all of that. But what Node really is like, you might have heard the term if you were looking online, runtime environment. But what is really a runtime environment, really? So you must understand that in early days of web development, like let's say 12 to 15 years ago, JavaScript was only made to run on browsers, basically for client-side interactions, like we saw it running on browsers. But then at some point, if my memory is correct, starting 2009, and thanks to Google's V8 engine that we will discuss now, we started using JavaScript out of the browser and replicate the browser environment outside of it. And that's how Node.js was released, as basically a way to write JavaScript on servers and have it run on the machine instead of basically being interpreted by a browser. Node.js is really good with HTTP and TCP and makes really writing server codes really easy and really quick. So you can get an API running with minimal effort. And basically how that does is goes through what is called the V8 engine. So what is an engine? Engine basically is, the engine is what runs JavaScript. And V8 is the engine that is found in Google Chrome. So basically, if I go here, I have Chrome open. If I go and let's say I go here and open the console. Second, if I go here and open the console, I will zoom in a bit so you can see it well. So if I go here and, for example, type math.random, excuse me, V8 is what runs this JavaScript to get this. So this goes through the V8 engine. The engine is what understands these statements. So that's what V8 is. Basically, it is Google Chrome's JavaScript engine. So it's not the only JavaScript engine around. There is a multitude of other engines. Basically, every browser has its own engine. V8 being, as of now, the most performant one, and which is developed by Chrome. For those of you who are curious, basically how that works is that you will have the JavaScript code that we are going to write, which is run through Node.js, which is basically this runtime that is made of JavaScript, and C++, which communicates with this V8 engine, which is basically made in C++ and use C++ libraries to communicate with the machine, basically. So these are theoretical concepts. They won't be very useful to you when you're actually writing the code. But this is how basically we are able to run JavaScript code outside of a browser. And this means that we'll have a few differences as well between JavaScript that we run on the browser and JavaScript that will be running through Node.js. There will be a minor differences that we will see today. So CLI. So CLI means command line interface, which basically means a program that runs on your terminal. And Node is more than just, the wrapper around V8 to run your JavaScript code. It's actually a full CLI tool. And when we install npm, you might have noticed that we have a few CLI tools that are installed. We have Node, which you can see here. I have Node version 12. We have npm, which is also a command line interface. We have npx as well that we used with React, which is a command line interface. And all of those are installed when we install basically Node on our machine. So Node can allow us to use a lot of things. If we go and type node -h, we'll get basically the help displayed with everything that we can do. Sorry. So these are a lot. We won't be using most of these, but some useful options that you can use with Node are basically -c, or --check, which will basically tell you if there are any problems with your script syntax without executing it. So maybe you're working on something and you want to see if actually there are any problems with it, but not actually run it. That's how you would do that. You also have eval, -e or --eval, which would evaluate your script and looks a bit like -c, but will still execute it. We have, for example, if we go down, we should see -v8 options. So -v8 options, basically these will be options that we run to V8. Let's say we want to change some things in the engine itself. For example, I don't know how many of you are familiar with the concept of a garbage collector. A garbage collector is basically a program that runs and watches as your program declares variables, uses them, and doesn't need them anymore. The garbage collector basically is a program that goes to the variables that you are no longer using and deletes them from your computer's RAM, so your software basically doesn't take too much RAM when it's running. Through the V8 options, you could, for example, disable the garbage collector if you needed to, but these are advanced things that you might not need at this level anyway. An important one, though, is going to be the environment variables. These you will definitely need. Basically, what is an environment variable? These are variables that you might find in your operating system. For example, here, my nickname is H2O. So if I go and do echo user, you'll say it says basically the user. If I go and do, for example, through Node, if I execute this Node script with, let's say, for example, I say console.log process.environment.user, what will happen is that, that's it. Oh, let's not use console.log. Excuse me. What is it? What's it saying here? Cannot move in video. Oh, let's say node, excuse me. Node, this will have open node repo. If I go and do process.env.user, you'll say it tells me the same that basically I saw on the terminal earlier here. So let's do it differently. This time use the option. Let's say user is go digital node. What you will see is that this time, if I go into process.env.user, it will say go digital instead of H2O, because I basically replaced the environment variable here. And you can use this for a lot of stuff when you're writing your node programs. Let's say, for example, you want to have a URL that changes. Let's say you want to say basically third party URL, third party API URL node, and then equal some HTTPS API.com. Then when you are writing basically your code, you can do, for example, process.env.third party API URL. And basically we will get the URL every time, and you don't have to write it everywhere. That's a good way of managing your constants through the application, basically. So that's one of the main things you'll be doing with Node. Another case where you would need environment variables is maybe where with Node env. Basically, what you would do with this is say, for example, development, or you would say Node env is production. So you can test within your code if you're basically I'll make the font bigger. So you can test if basically you're in production or in development and do things according to the environment you're in. So that's basically the main things that you might want to use as terms of options when you're running Node. Let's get back to the presentation here. So that's about the Node CLI. So let's try executing files with Node now. So most of you will know how to do this from the previous course, but let's create a project. Let's go workspace, go digital, and let's make a new project. Let's call it my Node API. Let's go there to my Node API and create a new file. Let's open it in VS Code, maybe. So now we have this new project. It's empty. We're going to create a new file that we'll call index.js. Let me zoom in a bit so you guys might see. Okay. That should be enough. Okay. So we'll write here a simple script. We'll just say console.log hello world. Let's open the terminal. Or maybe go through our regular terminal. So here we wrote this script saying hello world. All we need to do to execute it is basically go and do hello world or .index, we call it index.js, and it will say hello world basically. So that's all we need to do. It works basically like if you were writing to a browser's console. The same thing is, for example, if we did to illustrate what I was saying with the environment variables, we could, for example, give it here node conf equal development or production and do index.js. Here it changes nothing. It changes nothing, but if we go to our script, what we might do, we could declare, for example, here a constant is, or call it production, and we could say process equal production. And here you could say, for example, you are in or development environment. So once we do that, we should now see a difference. If we say it's production, it will say you're in production, but if we run it without anything, it will just say you are in development environment. And that's how basically we would separate if we want, for example, to use one database for development and another database for production when you're going to deploy. So let's get back to our presentation and keep going through the basics. So exports and require. This is an interesting concept because in Node, this is one of the main differences you'll first notice when using Node.js instead of the browser, is in that Node.js sees each file as what they call a module, and it's called a module system. And basically, you look at each file as being a module. And if you want to call a module, you would use require. And if you want to basically export something out of the module, you use module.exports. And basically, this might look like export and import that you would use in ES6. It is possible to use US6 imports and export in Node version above 13. But here we'll be looking at the main classic way to require and export because it helps you understand how modules work. Basically, here I'm using Node 12, and if I go and write import, it will basically throw an error. I will show you that in a bit. Let's say we want to write our first module here. Oops. Let's get back to our script here. And let's say we write a script called greeting or maybe let's create a folder we call modules. And we'll create a greeting module that will basically say hello. We'll have a function called say hello and a name. And basically what that would do is that will log hello plus the name. Basically, in how we used to do it, be doing export, say hello. But in here, it will throw an error. It will say it's unexpected, basically. Because what it expects is that you say, hey, module.exports .say hello or whatever you want is say hello. So this is basically the exports that comes from our module. And when we want to use say hello, we'd come here. And instead of doing, if I do import, for example, say hello from modules greeting, this shows no error here. But so if I go and do say hello to go digital, it should, when running, since I have node 12, it should say, hey, import is not expected. It says, warning, to load an ES module, set type module package.json or use the MGS extension. Because it is still an experimental feature at this point. It doesn't like imports. You would need to use a later version of Node.js, like I said, but for the sake of this course, we'll be following the older way to do it, because that's the way that basically will work every time. So how it would do then is that we will basically say a constant, say hello, equals require, not import. And what we will require is that we go to modules, greeting, dot say hello. That's how basically we would call our say hello, or we could just go like this and get rid of that. Now it should work as expected. Let's clear this. And when we execute, it should now say hello, go digital. So that is basically how the require and export works. Keep in mind, we could also have a shortcut and say, instead of using module.export, we could use exports directly. Function, say goodbye, for example, name, and we could have it here, console.log, goodbye, name. And we could use, instead of module.export, directly use exports, and that will work fine as well. If we go here and import it the same way, say goodbye, it should work as expected, even though we didn't go through module and used exports directly. So there. That's how we basically call other files and other modules. You shouldn't mix modules in a single file. So every file is considered the module. You can't have different different modules sharing the same file. Are there any questions up to this point? Or is it clear for everyone? I mean, we're going through the introduction here. It works with anything. Actually, we can have we can export anything from a module. We could have a function like this. We could have basically we could have exports str is a string hello. We could have numbers. We could have booleans. We could have objects. we could have basically anything, and it would be returned as a JSON. Basically, if we look here, we could go say here, for example, instead of say goodbye and everything, we could say a constant here is the greeting module. And if we here go const from greeting module, if we were to console.log the whole greeting module, you would see that basically everything is there. See, the greeting module has say hello, which is a function, say goodbye, which is a function, str, which is basically characters, numbers, booleans. We could have arrays as well. We could have basically anything going through our exports. So another question I see here is the difference between line 9 and 10 in greetings. Iman Ibrahim asks. So difference between these lines is nothing. Basically, there is no difference. What Node does is when it sees exports, it will add module dot exports if you didn't do it. So when it sees exports alone, it will inject module dot. So basically using this or this is the same. It's exactly the same thing. As you can see here, if I go to exports, it will say it's from this module, and every module contains exports. But export will basically go and be injected in module anyway, even if you don't write module. I just wanted to show you both writings. So if you see them written differently, you understand that it's exactly the same thing. So if there are no other questions, let's keep going with the course. So we saw how to execute our script, we saw how to require different modules. Let's quickly talk about callbacks and promises. I believe you saw promises with Mr. Safadi during the introduction to JavaScript, but we'll look more into it in the context of Node.js and why it's even more important. And we'll talk as well about callbacks, since they've been here for longer. And for Node's APIs and core libraries, you'll see callbacks used way more than promises, as we will see. So basically, in a synchronous program, in regular synchronous programs, what you could write, for example, a function with process data, and you'd have basically a function that fetches and returns your data. Let's say your data is a number, for example, fetch data returns, let's say 10, and you want to go and add 1 to this 10, it becomes 11, and then you return 11 at the end of the process data function. Node.js being a synchronous platform, it doesn't wait for things like inputs, outputs, and asynchronous operations. So what would happen in this case is that data will be returned without waiting for fetch data to basically get the data it needs. Let's say your fetch data calls an API, it's not instantaneous. So you will be, fetch data will be running for a second, and Node.js will not wait for that second to be done, and will just keep running the code. So usually how Node deals with that is through callbacks, even though on our courses, we were more used to promises. Basically, a callback is a function that you call when a task is complete. And this prevents basically needing to block with awaits or other things like that. It is a good way to basically keep going with stuff and do something else when basically it's ready. So we'll demonstrate that in code. For example, Let's go, let's get back to our VS Code and try to write a function callback. Let's add a new module. We'll call it I don't know, let's call it callbacks. And here what we'll do is that we'll declare a function called delayed high. Or let's not declare a new module. Let's keep working with our greeting module. Let's delete this. Actually, it might be a better idea to keep going here. So let's go and go to this function goodbye and change it a bit. So let's say goodbye. What I want to do is that I want to run. I'm going to make another function called get name. And what I will do here is that basically, let's get rid of this. And we'll go and set timeout. We'll wait for 2 seconds. And then we'll return go digital. If we go here and say, for example, name equal get name, and we say goodbye.name. Basically, let's get rid of this. And here, return go digital. So yeah, say goodbye. So let's see what that does. Let's go, and you'll see here, it says goodbye undefined. So why is that? It says goodbye undefined because basically it will here console.log goodbye.name, even though this hasn't returned yet. So it doesn't wait for it. So before going, Ibrahim says, why we use modules, not libraries? I mean, these are not different in essence. A module, you don't use modules or libraries. So libraries are basically in Node.js, libraries are a collection of modules. In Node.js, every file is called a module. You don't say, for example, you don't call it a script, you call it a module. You don't call, so files are modules, and libraries are a bunch, Node libraries are a bunch of modules put together. So it's not libraries or modules, and we are not using modules and not libraries. They're not fundamentally different. They're not alternatives to each other. They're fundamentally different concepts.
هنستخدم async و await.
As for what we're saying now with the callback, yes, we will use that instead of async and await. It is a different way to do things. Why are we seeing it together now instead of just keep using await and async? It's because when you're going to use Node libraries, and especially Node core libraries, you will notice that a lot of them still use callbacks. They don't use library, they don't use promises. So how you would turn this into asynchronous without using promises, with only callbacks? What you would do here is that you would, with get name, give it a callback function. And instead of returning, you would run basically a callback. That's all you need to change. And then when you come here and get name, what you will do is that you will give it the callback parameter. A callback is always a function. And what you will do is that everything depending on the name, you will do it here and give the name as a parameter. That is basically a callback. And if we execute, and you'll see, for example, here, even if we write something after get name, let's say other code, even if we write it after get name, since we're not using await, and that's the advantage of callbacks, because await always waits before executing the rest of the code. We don't need blocking with callbacks. When you use callbacks and we say here other code and it comes after it, if we execute, what you'll see is that it says other code and then says goodbye, go digital, even though basically the goodbye comes first, because await blocks your process, while callbacks doesn't. It doesn't wait. And that's the issue with async await if not done properly, is that you're blocking and technically slowing down your function. So let's get back to the presentation and we'll see more about this. Mohammed Safadi says he's not hearing me. Are you guys hearing me, or is it a problem? Is there a problem with the sound? Can you still hear me?
No problem.
No problem. Okay. Okay. So I was saying you're used to async waits and promises. So promises are good nonetheless, and I actually prefer promises. And a way to basically handle what we did with the promise is that let's have another one called function get name. Let's call it get name promise. If we do this like this and we say, for example, return new promise, it takes resolve, reject, reject. And let's get here and basically, excuse me, and have the same here, but instead of callback, we'd have resolve here. And instead of, let's say, let's go now and do, let's have it async function. And if we do here await and await, let's say const name equals await get name promise, and then do console.log promised goodbye to name, and have another console.log other code again. If we go and execute, the main difference that you'll see now is that other code is executed while other code again basically waits for the promise to resolve. So await blocks our progress. It basically blocks it. It doesn't allow for the code to continue running until basically the promise resolved. That's a problem if the rest of the code is not dependent on the result of the promise. I mean, even without await, we can basically solve this issue with promises as well if we were to do something like this. If instead of this, we come here and have get name promise dot then name and say, let's call this second promised goodbye. And here we'd have first promised goodbye, other code 1, other code 2, and other code 3. Now what you'll see is that solve the issue. Wait, get name promise point then is not a function. Okay, I need to execute this first. Okay, clear. If we run this now, you'll see that other code 1 and 2 are executed directly without waiting. Or the only one that is delayed is other code 3, which is the one that comes after the await. And that's basically the issue, only issue with await, is that you should not use it and then have other code that doesn't depend on it, because it will basically block the rest of the execution of the rest of the code until the await is done. So is that clear, or do you guys have any questions regarding that?
You mean async and await blocking the other code?
Yes, as you can see in the console.log here, Hossein,
Yes.
other code 3 is not executed until the second promised goodbye, with the one with the await. So basically the await is blocking its execution.
The
Look
best
at
practice using promise?
When using promise, you should never have code that doesn't depend on the result of the promise and put it after the promise when using await. So it really depends on how you write your code. But if you're using async await a lot, make sure you don't put await and then put other code after the await that doesn't necessarily need to wait for the promise. Only put things that need to wait. Things that don't need to wait, you shouldn't put them after the await.
Okay.
Is that clear, or maybe?
Clear.
Okay.
Okay.
So these are the two ways to execute promises, and callbacks don't have that issue. Callbacks don't have that issue at all. Basically, things that depend on the callback, you would put them inside the callback, and that's about it. So that's basically how callbacks and promises would work, even though I think you already understand promises quite well. But there you go. So we've seen callbacks, we've seen promises. You have other examples here in the presentation. Let's look at something that we don't know and we haven't seen, that we've seen only in the browser, which are events. You'll see them happen a lot in Node. So it's a very important concept to understand. So events, you should be fairly familiar with events from the browser API. You guys remember, if we come here and have, document dot get element by ID or something, or document dot or window, whatever, and we could add an event listener and add the type of event. Let's, I don't know, load or resize, for example, and have it say, I don't know, give it basically what you want it to happen. .log hi. Oops. I don't know if that works if I do it here, but basically what that will happen, well, it doesn't happen if we don't write it to a file, but basically you get what I mean. You could add event listeners this way, except window and document don't exist in Node.js. If I go and, for example, I know you're used to JavaScript, but if I go here in the index and I console.log the window or the document, anything related to the DOM or the browser API. What that will happen is that it will say window is not defined. And let's go here. Let's do like this. Window and document is document. So it's clearer. You'll see that basically it always says window is not defined, or if I get rid of the window, it will say document is not defined. Because in Node.js, these things that are related to the browser don't exist. We're not running in the browser. So there is no window and there is no document to attach event listeners to. So how do we handle events? We need real cases for promises and callback to know when we put promises. You can use promises anytime, to be honest, but callbacks we will have a concrete example later on when using basically the file system. We'll see more concrete examples later in today's chapters, but you don't really need to know when to use promises and when to use callbacks. You can use whichever you want, to be honest, but you need to understand them both, because you'll find libraries that want promises and libraries that want callbacks, especially if you're working with libraries that you have not written. Because when you write the code, Iman Ibrahim, you are free to choose. You can choose to always use promises, and it's okay. You can always use promises. It's fine. But when you're working with libraries you have not written, the person that wrote the library may have chosen to use callbacks and not promises. So it's important that you know both, but you can use either depending on what you're more comfortable with. Keep in mind that promises didn't always exist in Node.js, and they are fairly new, let's say. It didn't exist in the beginning. The original way to handle asynchronous operations in Node is callbacks. Then they added promises, and most people started using promises, but not everyone. So you might encounter callbacks, and we'll see real life examples later on today. But that's really you just need to know what it looks like and why it exists. But you are definitely free to always use promises if you want to use promises. That's your choice. There is no right or wrong choice here. The only thing you need to keep in mind is not even related to promises. It's the async await statement. You should, like I said earlier, when you're using await, you should keep in mind that everything that comes after the await will wait for the await statement. That's it. Apart from that, definitely use what you want. So where were we? We were talking about events. Yeah. So if we don't have the browser API, it means we don't have the add event listener statement. So how do we handle events in Node.js? So Node.js has a core API, a library written by the guys that made Node, which basically added these so we can handle events. So how that works is that Node is built around these. You'll see them a lot with event-driven architecture, is that they have what they call event emitters, which are basically event triggers. If I were to explain it with an example from what we use in the browser, on click, the clicking is an event emitter. So all we need to do is that we emit events from specific parts in our code, and that's it. So basically what that means, let's say, for example, I want to use it for asynchronous treatment, and I don't want to use neither promises nor callbacks. what I would do is that, and it's better than those when it's long time. Let's say if you're waiting for an operation that lasts 2-3 seconds, callbacks and promises are fine. But what if you are waiting for something that might last hours and you're not even sure it would happen? Basically, what you would do is that, let's get back to our code and write an event emitter. So what we would do is that, okay, so let's get back to VS Code. Let's get back to our greeting file, and we'll require, like we saw earlier, we'll require the event emitter from basically the events API. If I'm not mistaken. Okay. Then what you would need to do is that you would use an event emitter object, which is a new event emitter. So now what we need to do is say, for example, here, what we want to do is that when we say, let's say we want to do here, event emitter, well, on, like when we write the event listeners, so on what? On name received, or let's say on what do we call it? What should we call it? On
Button clicked.
no, but there is no button here. So let's say on hi or on press, or on press, we should say hello to you guys. Okay, say hello, and we can basically, let's put it in the index. Maybe it's better, so we don't have an overcrowded file. Okay, and let's have it here, and it's called actually on start. On start, let's get rid of hello, say hello, or actually, what say hello here, say hello. Let's keep it there and say hello again, or go digital event users. And what we will do is that we created an event that's called start. Now what we need to do is that, let's put this here actually, where we have our requires. And what we will do is that we need to emit it now. We'll say set timeout. We'll wait for 3 seconds, and then we'll emit start. Basically, it means to trigger.
Event?
That's triggering the event. That's the main difference between what we do on the browser usually, and we do that we trigger our own events. They're not triggered from the DOM because we have no DOM. We emit our own events. If we have another event emitter on, let's say calculate, we could have here a function that, excuse me, that returns console.log 5 plus 5. And we could have another timeout at 4 seconds. And this time we'll emit calculate. So what we'll do is let's get rid of say goodbye, because it takes space in our terminal, and let's execute. What is happening here? Must be of type function received undefined. Where? Okay. Did I not give it a function? Oh, you are right. It needs always to be a function. So here, let's do this again. Let's clear the terminal. And do this. You say hello, go digital. It waits 3 seconds. It emits the first. At 4 seconds, it emits the second. So basically, whenever we emit, this triggers this function. And we could emit it as many times as we want, actually. So if you want to have another timeout here at 4 seconds and a half, saying start again, and then another one at 5, saying start again. Basically, that will run the function every time we emit the event. See? Yes, man, Ibrahim, it's emit means, it's not the event listener. The event listener is the on. On is the event listener. Emit is event trigger. Basically, they're like the clicking when you have an event listener in the DOM. So basically, in the DOM, we bind events to things happening in the DOM, right? For example, you add an event listener of clicking on a button, and then clicking is the trigger for that event. In Node, we don't have a DOM. We don't have a button to click and basically trigger our event listener. So we emit our own events. See? Instead of having the actual click, what we could do here is that, for example, what we do is here is, maybe it will be clearer like this. Let's say here on click. Okay, this is like the DOM, right? And what we do is that we create a function called simulate click, because we have no button to click. And simulate click is this. Okay, and then we can replace all of these with, I'm sorry, with simulate click. Basically, you are here, we are faking a click. Okay, and it will give us the same result. Basically, I don't know if it's clearer, Imam Ibrahim, but we have the on, which this is the event listener. Okay, this is the event listener. Okay, this event listener, and this is what we call an event trigger. We didn't see event triggers in the DOM because the DOM actions are event triggers. Here we don't have a DOM. We don't have buttons to click. We don't have inputs to change. We need to trigger our own events. Good question. The second parameter is a function. Is it a callback? Yes, it is a callback. Exactly like when we're using the event listener on the browser. The second parameter needs to be a callback that is executed when the event happens, is triggered. So yes, it is a callback. Good point.
It's clear.
Okay. So this is how we handle events in Node.js. It can be, in any case, you might need to have events. For example, sometimes you will see that, we will see that when we're doing HTTP later on in the chapter. It is very useful, for example, when, let's say you want to bind an action to whenever you get a request from HTTP, right? you basically will have an event listener on HTTP requests, and you would trigger, you would have an event listener saying on request. And the HTTP library from Node, what it does in the background is it basically emits a request whenever a request comes to your machine through HTTP. So we'll get back to that in a more concrete example. Let's
5 minutes, please. Electricity, come back.
yes. Tell me. Okay, let's maybe clean our code in the meantime. Let's have another module maybe here so we don't clutter our index. Let's call it event. And we'll do everything here. Excuse me. And we can just here without anything do require modules events. For those who do not understand what I just did, basically here when you require without get, when you require a file, it takes the whole file and puts it here. It's like if we wrote everything that exists here there. So if I just go and execute again. Okay, new event emitter is not defined. My bad. I forgot to take this with me. There we go. Say hello is not defined. Yeah. I need to add say hello. Equal require greeting. So this should still work. And it should be cleaning our index so we keep it small and clear. There we go. So let's get back here and keep going with our course. We'll be taking a 15 minutes break in a bit, so let's see where we are. Keep with me for a while. Reading from, let's go through this now. So reading from the file system. This is a really, really, really interesting topic. Because when you have basically your code running on the server, you will need to access some files, maybe images or something that you want to send. And basically, you would use here DFS Node Core Library. It's a library that is available through Node, just like events, which allows you basically to manage your files. It's as easy as that. So it allows us to create files, delete files, edit files, a lot of stuff. You will find the whole documentation on the Node API website. And here, as you can see, and when Ibrahim, especially you asked the question earlier, you can see that FS here uses callbacks, except they released a new version that basically you call through require FS promises to get promises. But you can have either callbacks or promises in the case of file fs library. So Yunus asks require versus import and export. So I explained this earlier in the course chapters, but here it's basically not a huge difference. The way Node.js works is a bit different from how your browser works. So there are minor differences in between Node and browser, basically JavaScript, even though Chrome and Node run through the same JavaScript engine, which is V8. Since Node 13, you can use import and export. You can just not use require. But the original way to import and export modules is through the require and module.exports expressions. Because it is because we are using modules and not just simple script files like we do on the browser. So if you don't have Node 13 plus, import and export will just not work. But otherwise, it works the same. There is really no difference here. It's just that Node's original way to handle module exports and imports is through the require. Because it existed even before ES6 and what ES6 brought in terms of new wordings and new expressions. And keep in mind that as terms when you're hosting Node.js, you won't always find hosting services that have the latest Node.js version. So it might be good to understand the original way because it always works. Basically, if you use require, it will always work. But otherwise, it's the same thing. So let's keep going with the FS core library. Let's basically try it out. Let's get to our code. Let's get to VS Code and try to play with files. We'll add a new module here, file manager. We'll call it file manager.js. And it's a new file. And what we wanted to do is basically we'll call it, we'll have, of course, we'll need to import. So we'll have fs equals require fs promises if we want to have the promises. And otherwise, if we use fs only, let's have it promises, and let's have another one, which is the regular fs that you will see uses callbacks, but that's the only difference. So let's say we write here a function called create JSON, and we give it a JSON obj, we give it an obj, and we want it to basically write a file. What you would do is that basically you would do a synchronous function here. And what we would do is that we would basically await. Let's have a try catch here. So we could catch errors. We could return promise dot reject error. And here, what we would do is that we would go fs promises dot read file or dot write file, dot write file, and we'll give it a path. Basically, we'll say we'll call it my JSON.json, and the data I want it to be JSON.stringify the object that we received. And then we'll go and export it, create JSON, it exports dot create JSON equals create JSON. Okay, so how that would work now is that if we go here and basically file manager module require modules, file manager. We could have here, let's not call it this, let's have create JSON. And what we can do here is that let's actually get rid of these. What we'll do is that we'll come here and we'll create a JSON, give it any object that we want. Let's call it, let's have him have first name John, last name Doe, and try to execute this and see what happens. Let's get back to our terminal and execute. Whoops, we forgot the .js. Cannot find module fs.promises. What do you mean? Do I not have the right version for the fs promises? Oh. Let me take a look. Maybe I don't have the right version here. Let's see. Okay, it seems they changed it to here like this dot. Okay, so now, okay, so they changed and then it works like this now, dot promises, dot write file, if you want to use the promises. We'll need to await it, of course, and we'll say here, return true or anything. And let's try and execute. So now we should be getting let's get back to Visual Code and we should find the file called myJSON.json with basically the data that we wrote. Another way we could do that is through callbacks. Let's keep the promise and write another file. Let's have fs.create not write file and have it write hello.txt. Have it be hello go digital students. And we could, that's the data. And then we need to give it a callback function because it's a callback. And here we'll say, for example, console.log success and writing file my JSON.json. And here we'll have it here. Console.log and hello txt. What's happening? Did I forget something here? Oh. There we go. If error, return throw new error. So we can fall into the catch. Okay, so now if we go and do it, we'll see that we wrote two files, one with the callbacks and one with the promise. We'll find index.json with first name, last name, and we'll find hello with hello go digital students. So basically, that's how we would write files. We could have also a function here to delete. Basically, we would have another one here. We'd have await fs dot onLink. And what this does is that we'll give it hello.txt and success in deleting file hello.txt. So now if we execute, we'll see that, okay, callback. Okay, okay, it's that promises that unlink. Sorry, I'm using a promise here, so I need to do that. So you'll see that we're writing hello.txt and we're deleting it at the end. So now we'll not find it here. So that's basically the main functionality of the file system. That's how it works. Going forward, we'll see more complex ways to handle files using basically streams, which is more complex, which we'll use to handle bigger files, for example. But in the meantime, do you have any question with what you've saw until now? The unlink deletes. It deletes files. Basically, it deletes file. You give it the path, and it will delete it. It will delete a file. It's useful, for example, if you want to create a file, use it for something. For example, if you want to download it and then delete it, so you don't fill your storage space. You create a file, send it through HTTP, and then delete it, for example. All unlink does is delete. We'll see, like I said, more complex ways to handling files with data streams that are very important for bigger data. But first, let's take maybe a 15-minute break if you want, so you can rest a bit before we go into more complex subjects. Because we are done with the introduction. Now we'll be going into things that are a bit more complex. So see you guys in 15 minutes, okay?
Okay.
Cool. Take a break and see you guys in a few minutes. Hi again, is everyone back from their break? Good. Let's get back into the course then. Good. Let's get back to it. So data streams. Just before the break, we stopped while we were using the file system. We're creating files, deleting files. Well, there might be an issue, for example, when you're using large file. Let's say you have a video, or you're building the next Netflix, okay? You're building a video streaming platform, and you need to send the video basically to your to users. The problem with large files is that if you read them or write them the way we did, basically they're read into the RAM of the system and then sent. Let's say you have a full HD movie with 2 gigabytes. That means that you're taking 2 gigabytes from your server just to read and send that file, which is not good because we have limited RAM on our system. So the way we deal with that is through data streams. Basically, what that means is that we're going to read data bit by bit, and we're going to read it through basically streams and events. So let's try to write a big file, like we can see in the example here. So let's get back to our code and try to build a big file. Thank you, Mazoun. I'm not sure I pronounce your name right, but thank you for not letting me walk alone. So let's get back to the code. Here, we're going to try to write a big file. So what we will do is that we will first create a write stream. It's like here, to show streams, to write big files, it would take a lot of RAM if we want to write a big one. So what we'll do is that we will use a write stream, which means that we'll be writing the file bit by bit. What does that mean? Okay, let's create a function. We'll call it create big file. And what we'll do is that we will basically first create a file that will be fs.create_write_stream. This is a data stream. And basically, we want to just give it where we want to save. We'll call it big file.txt. And what we'll do now is that we'll write, like I said, with streams, we write to file bit by bit. So let's create a loop. And in this loop, what I want to do is that, and I wanted to go very, very far. So how I'll do that is I'll use math, okay? So what I'll do is 1e6, which is basically 1 exponential 6 for those who did math. Exponential, which is a big number. For those who don't understand what I mean, this is it, exponential. Basically, with exponential, the curve to increasing value is like this. 1 second, let me show you. For those who don't understand what I mean by E is basically, let me close this. Okay, my computer seems to be slowing down. Okay, exponential, which is a mathematical formula It's a mathematical function, excuse me, which is basically grows like this. So exponential of x grows exponentially. When x increases, you'll see it increases by a lot. So what we're doing here is basically we're looping from zero, excuse me, to exponential of 6, which is basically a big number. It's like we could say from 0 to 1,000,000 or whatever. This is just more convenient. So what we'll do is that for every iteration of this, we're going to write a new bit to the file. We're going to do file.write hello. We'll add hello to our file. And basically when everything is done, all we do to say that we finished writing to our file, we do file.end, and it will close the stream. Okay, so let's try to use this function to see if I didn't make any mistakes. We'll come here and we'll ditch this and we'll add a function here called create big file. And what we'll do is that we will basically create a big file. We don't need any parameter. So let's get back to our terminal and try to create this big file. So it should be done. Let's go and see if it was done correctly. Let's get back here. And we should have big file.txt with lots and lots and lots of hello. Like you can see, this is a lot of hello. So this is what we tried to do. Let's go out of curiosity, let's go take a look at how much this file weighs. So this file is 4 megabytes, okay? I didn't go overboard, but this could potentially be bigger. 4 megabytes is still okay. Let's make the file actually bigger. Let's go E9 or E10, exponential of 10 even, and see how big we can get in terms of file size. So it takes a fair bit longer to create the file. I hope it's not going to be too big and crash my computer, but okay, this should be huge. Okay, maybe we should make it smaller. Definitely we should make it smaller, because at this rate my computer is going to crash. And we don't have time to wait an hour to write a file anyway. So let's write a file that is a bit smaller. So we should be done writing the file. Let's see, it should be way bigger now. VS Code has even trouble loading it, as you can see. And well, let's take a look at how big it actually is in real life. The file is actually now 47 megabytes. And as you can see, that might slow down our computer quite a lot if we were to read the file directly. So like we wrote it bit by bit, the good way to handling reading the file is bit by bit as well. If we were to, for example, here, read big file, and we were like here to just, Restream. And if we were here now to, try to read it and be like fs.read file, and we could have it be big file.txt UTF-8. Encoding UTF-8 because it's text, and then we would have a callback, error, data, and we would console. Okay, we didn't close this. What is missing here? Okay, this is good. And we were here to, let's say, console.log data. If we were to do it this way and add here read big file, whoops, we don't need to, okay, read big file here. Oh, we didn't add it here. We need to add it to the exports, read big file. And if we try to read it this conventional way without a data stream, let's actually read the big file here. And go back here and look, this will happen. And all of this is taking gram into our computer. So we don't want to read it at once like we just did. This is only 47 megabytes, but if it were actually even bigger, that would take even more RAM. This is only 47 megabytes, so it's okay. It's still okay. It won't crash my computer yet, but it could be a bigger file. This is just for the example. If we went bigger, that would be even more of a problem. So we don't want to do it like this. Let's keep this actually here. So you have an example, read file, or read, we could have it read, we could change it actually and say read create JSON file, and we give it a path, and we could have it here. The path here. I'm going to create another function here to read our big file, which is more adapted to reading big files. So using a data stream. So we could have here now read big file. And what we'll do is that we'll this time create a read stream. Okay, like we created a write stream here. We created the write stream. Here we'll be creating a read stream. So we'll be creating a new read stream, const read stream, which is equal to fs create read stream, and we'll read from big file, big file.txt. Okay. Now what we want to do is that we want to add event listeners to my read stream. So I wanted to say, hey, read stream dot on what is it called already? I forgot. It's called data. Okay. So if the data event happens, basically what that means that this event happens when this read stream is receiving a chunk of data. Like we said, when writing, we wrote bit by bit. When reading, it would do the same. So when we receive data, what we want to do is that we'll be getting a chunk as a parameter. And we want to do is that we want to, we want to log, received chunk. And I wanted to give you basically what that chunk is. What is the chunk that we received? So now if we go and this will be very useful when we get to HTTP, where we'll see it more in practice when we want to send data through HTTP. But now, for now, what we'll do is that if we get back to our terminal, it will send basically hello, 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 hello again, depending on us, but it won't do it at once. It will actually be loading like this as it's getting chunks. Okay. As soon as it gets a new chunk, as you can see here, you see received chunk. So maybe we'll make it even clearer so you might see it. Let's add here. Where is it? When we do a chunk, when you receive a chunk, let's have en, and have maybe a separator here, and have another and received chunk. And what that will do now, let's see, is that it reads by smaller chunks. If we stop it, we'll see that if we go up, we should find at some point a separation between chunks. See, this is a separation, then we have a new chunk. So it doesn't read it all at once. We get smaller chunks. So it splits, the bigger the file, the more chunks it's going to have. See? And what that means is that basically in HTTP, that means instead of sending our users a video of 1 GB, we'll be sending bit by bit, chunk by chunk. Chunks being smaller, chunks being, for example, 2 megabytes to 5 megabytes per chunk. And that's why basically when you're watching videos, for example, on YouTube, you don't sit and wait until the whole video is loaded. You watch while the video is loading. And that's how it's done. It's because there is a read stream. And that's why we call it streaming. That's why we call it streaming videos, because it's a data stream. And that is what we are doing here. Basically, we are streaming a file. It may not be a video file, but what we are streaming is a text file. And to do it with video, it's exactly the same concept, except we'd be sending bytes and not just, letters, random text letters. We wouldn't be sending hello, hello. You'd be sending video bytes depending on the encoding of the video. It depends if it's MP4, whatever. But that's how you stream data. Basically, that's what we just did. So do you guys have any question regarding that up to this point? Let's get back to the code, maybe.
How to read the bytes?
Bytes is actually the same thing, but we would be having, instead of a text file, we'd be having something else. Maybe we don't add the encoding here. Since here now we were using txt, let's try it. If I don't encode it, does it read it as bytes? I don't think so, but because it's text, but it's the same. But it's going to be the same thing. But I don't. Let's say I do it with. Let's say I don't do it with text. Give me a second. If I do it with an image, for example, let me take an image from a drive, and you'll get what I mean. Let's take a screenshot I have here and put it here. Let's call it my image and do the same thing that we just did, okay? Let's close this, and instead of using a text file that is readable, we will create a read stream to my image.png, okay? And now let's take a look at what that will give us in terms of the console. See, we will receive encoded data bytes. So basically, it doesn't change anything, actually. It doesn't change anything to how we would approach it. A file is a file, in essence. It doesn't change much. We just won't be able to display it on the console.
Yes. Could we determine the chunk size, or it's by system or node?
That is a very good question. Actually, if you go to the API, let's look it up together. Most of the time, it is defined by default by the API. But it's definitely a good question. So I suggest we look it up together. Let's take a look. FS Restream chunk size. Changing, and you'll find, we should find it. Do we have anything here? Stream size. So is it? Well, I thought I saw it here. So yes, actually, as you can see here, you can use high watermark in the right stream as an option to set the chunk size. So let's take a look here at high watermark node fs read stream high watermark, and there it is, high watermark. There, here it is. So we send it as an option, and it's a number, and it's going to define basically how big the chunk is in bits. Does that answer your question?
I will try it in an example.
Basically, it's like this. I'll do it for you if you want. It's like we can come here and we do the Restream. We add an option here. We give it high watermark, and we give it, let's say, we want it to be very small. Let's say 128. Okay. This means 128 bits per chunk.
Text file.
Let's get back to the text file so it's more easily read.
Yes.
So it's clearer for us, and let's see if this works. So let's clear our console and do this. See how chunks are small now?
Yes.
Contrary to earlier.
Very good.
So that is it. If you want to define it, another chunk size, not the default one, if you want the chunks to be smaller. I see a question here by Ahmed Abu Bakr who asks, read and write files from end to absolute paths. That's definitely possible. All you need to do is basically write your absolute path here, /home, check what do you want. Let me go check an absolute path for a second. Let's get the absolute path of this. There we go. And
is there a function to get the absolute path?
Yes, actually, we could get the absolute path in this manner. And 1 second, I'll show you that. First, let me show you that this works the same. If we do it now, see it still works. So it works with absolute and relative paths. If we wanted to get the absolute path, like you said in your question, we'd use a library, actually a default library in Node.js that is called path. Okay. And what we do here is that we would, let me get rid of this, it's too big, I don't like it. Let's say const absolute path equals path dot directory name. That's how you basically do it. And well,
Dir
the
name,
directory.
I think
Yes.
the parent directory only.
Yes, but then you need to, of course, navigate to where you are. That will always give you the parent. That will always give you the directory where index is. Then you need to navigate yourself from there. You need to do it yourself. It will only get you as far as, like you said, if you do it like this, absolute. You need to path.join, absolute path, and for example, modules, and for example, file manager.js. You need to do it like this with the path.join. Project dir. Let's see. Okay, let's not console.log so we can get. Wait a second. The path argument must be of type script, string, received undefined. Okay. Okay, we don't need anything here. 1 second, I may be doing something wrong. Uh, 1 second. And then what am I forgetting? Did I forget to put this here? Maybe. Ah. My computer is slowing down a bit. Let's put point here. So let's see if that solves it. So still gives me modules.file manager. Dear name. There we go. Does that answer your question regarding the root folder? Regarding the absolute path, basically. All right. So we'll need to call the I will create a function for that, get absolute path. File. And I'll copy this here. There we go. Make this a bit bigger. And there we go. We have a function to get the absolute path as well. So that is clear. Let's go forward with our next chapter. But before that, does anyone else have any questions regarding data streams?
No, it's simple, but needs more practice.
Okay. So I will actually rename this modules file to examples, so you can actually easily find them when reviewing. I'll go to my index and change these to examples. Okay. Let's now get rid of this as well and continue on with the course. Okay, let's go back to the browser and to the presentation. And next up, we have how to basically watch files for change in development. What does that mean? You notice that when we're working, every time we make a change, we basically have to run node again. So every time we make a change, we go back to the terminal, we press node index.js, etc. We always do that, right? Well, there is a tool that is used for development that is called NoDaemon. Excuse me. It's called NoDaemon. And what NoDaemon does is that it allows us to basically have that step done automatically for us every time we change a file. So NoDaemon will watch our files, and whenever we save a file, NoDaemon will execute node index.js for us instead of us having to do it. So that's very practical when you're actually in development, because you don't want to be going back and forth, back and forth, back and forth. So we need to install the dependency. As you see here, we have no package.json. We need to turn this into an npm project. So what we will do first is run npm init, right? We'll give it a package name. By default, it's my node API. It's fine. Version 1.0, no description. Index.js is the entry. No test command, no git repository. We won't have anything here in terms of configuration. So this should create for us a package.json. If we go back to our VS Code, we now see that we have a package.json with everything. So we'll delete whatever we don't want. And I don't want any of this. I'll just put my name here. Okay. And now I want to create what I want to do is that I want to create a start script, right? And this start script, what it does is it goes and executes my index.js. So it runs this command. So now in my terminal, I can use npm start to run my code. Let's get back here and uncomment the read big file. And now if I do npm start, it will basically start reading my big file because it runs node, but it's still, every time I make a change, let's maybe take something that takes less time, say hello. And every time let's say here, I do npm start. Okay, what did I do? Not undefined, okay. Okay, examples, events, and I need to uncomment this. Okay, so now it should run, but my issue is it will run and shut down. And every time if I want to go change here and say, for example, go digital students, I will have to go back to the terminal and do npm start again, right? So now we're going to install NoDaemon to solve that. We're going to go npm y for development only, -d, -- save, NoDaemon, because we only need it for development. And this will install NoDaemon for us. Let's wait for it to finish installing, and it's done. So now if you get back to our VS Code, we should see that in package.json, we now have dev dependencies, development dependencies with NoDaemon. And we'll add a new script called dev, which will basically run no daemon index.js. And or no daemon of this whole project. And now all we need to do is come here and do npm run dev, npm run my development script, and you will see it starts and goes, hey, no daemon version, we're starting node, and hello to Go Digital students. But now, if we go to our index.js and change students to trainees, you'll see that we don't have to re-execute anything. If we go back to our terminal, it will have executed for us already. So every time we make a change, it is taken into account and restarts without us having to close and start our server again. And that's very important when we're running an HTTP server and we don't want to be closing the server, opening the server whenever we want to make a change, especially in development, right? Only in development. Is that clear as to why it's useful and how we add it to our project? Or do you have any questions regarding no daemon?
You mean while developing, I can see changes on terminal?
Yes. Yes.
Uh-huh.
Basically, it's like when you develop React. If you remember during React, when you're using React, we don't have to run npm start every time, right? You run npm start once, and whenever we change the code, it changes in the browser automatically for us, right?
Uh-huh. Yes, I was thinking that is about the file manager when updating or deleting or creating.
Yes, that is it. It's called a file watcher.
File watcher for my code, index.js.
Yes.
Not
Yes.
files I create or delete.
No, but the file watcher watches the files that you create or delete in the code as well, not only the files that change. The file watcher watches all files in your project. And whenever there is a file that changes, or there is a file that is created, or a file that is deleted, basically it will run again.
Yes, I got it.
It's the same concept that we have with when we run React and we don't restart the project every time. So basically we launch no daemon,
Yes.
and it will watch our files. And when we work, we don't have to launch on the terminal again and again and again. It will do that for us.
Yes, React don't need for refreshing.
Yes.
Uh-huh.
So no daemon makes it so that when we're writing Node.js, it is the same. So we don't need to launch again and again.
Mm-hmm.
Whenever we make a change, it basically restarts for us. Like you see here, we had hello digital, Go Digital students, and then it's no daemon says restarting due to changes. So starting node, and we have the result again. And if we change again, it will do the same, exactly the same thing. Hello Go Digital. You will see it's no daemon will say restarting due to changes, and it will start again. And it will do that every time it detects changes in files. All right, so that's about it for no daemon. Let's get back to the next chapter. So now we'll be finally getting to the part you're all interested in. We're going to create a web server. We're going to create a backend with the built-in HTTP library.
Require HTTP? Yeah.
Yes, we're going to create an HTTP server. With Node.js, it's actually very easy. And what we'll do is that we will just need, HTTP is basically a library that Node.js put forward for us, and is designed to support many features of the protocol that are usually difficult to use in other languages like PHP and etc., especially with large and chunk-coded messages. We saw earlier how we can read messages in chunks, right? In most server applications, it is hard to read chunks and send them to user in that form, chunk by chunk by chunk, because it's okay to show them on the console, but it's a whole different story if you want to send chunks through HTTP, right? Because we're not going to get a request by chunk. We're going to get a single request. And so in particularly large chunk encoded messages, Node actually does it very easily. And we'll see that in an example. We go through the read big file and we'll send it as on our server. So another thing that is really good with Node.js is real-time sockets. And I mean, we'll see that maybe if we have time during this course. And now we'll start basically writing our first web server with Node, with using the HTTP library.
Yes, please, Express and socket. It's very important.
No, we are going to see Express, possibly sockets, but probably next week, not today. Today, if we have time, we maybe start with Express, but sockets will be a subject for next week, probably.
No problem. No problem.
So let's get to our code and get to writing code. That's the most fun part, after all. So let's get to our code editor and write a server. We're going to write a new file called server.js, and we will call HTTP. We will require our HTTP library, right? And what we'll need to do now is we will, excuse me. So we will create a server. Server equals http.create server. Okay. And then we will add to our server an event listener. Please remember how we saw events earlier. HTTP emits events whenever there is a request, and it emits a request called request. It emits an event called request every time there is a request through HTTP. Okay? So what we will do now is we need to make a function to handle the request and the response whenever there is a request. Okay? That is how we handle requests. And then we'll need to basically open the server on a port. We'll need to listen. We'll listen on port 8080. Okay? And here we'll say just something really simple. We'll write a header. First, we need the response. We'll go to write head. Whoops. Write head. And we'll write the headers. We'll say it's 200, so there is a success. We'll say, if you remember during our previous courses with CRUD operations and JSON, we mentioned this with MIME types. Please go back and review that course if you don't remember MIME types. So basically, we'll send our content type here in the header. We'll say we're responding with basically a JSON. And now we'll need to write the body of the response. So we'll go response.end. So end the response. And we'll send a JSON.stringify. And we'll give it a message, hello, go digital. So so this code, whenever we get a request on this server, on the 8080 port, we'll send back hello, go digital. So let's try this. Let's basically log all this. And we will just here require our server to execute and everything inside that file. Okay. Maybe we'll clean this file later on to put in the examples, but for now, let's just start our server. Let's clear this so it may be more clear. And so it says we started, there is nothing being said, but let's go back to our browser. Whoops. And go to localhost and open it on the port 8080 that we just declared. So see, we got a message saying, hello, go digital. So that's our first API, guys. Do you have any questions up to this point? Anyone? Any questions? It's all clear? Okay, it seems no one has any questions, so it's all clear. So let's move on. So there is actually a lot of things we can do with this. We can go here and have, I don't know, we can check the request first. Dot, I don't know, what should we get? We can display the request here. Dot, let's have URL and request.url and say hello. URL used is URL. And then what we can do is that if we go here, you'll see URL used is the root. And if we write localhost 8080, I don't know, test, you'll see now URL used / test. If we have another something else, let's say hello, you'll see that we get hello. So in this vanilla, let's say HTTP library way of handling the server, what we want to do is that we will have basically we'll need to declare our own controls. We declare, for example, say hello controller, which is a function. Say hello controller. It takes a request and response, of course, and we'll do everything here. We'll send it to here. We'll get rid of the URL. And basically what we'll now do is that we'll create another controller. It's going to be, say, goodbye controller. And we'll create another one called fallback controller. What this will do is to say, this will do 404, which basically means that there was nothing found. And it will return a message saying, please use /hello or /goodbye. And here we'll say hello, go digital. We'll say goodbye, go digital. And here, hello, go digital. And here we'll say goodbye, go digital. And what we'll do is that here we'll do something called we'll create our router, and the router takes the URL. And what it will do is that we will have a switch case URL, and we'll say request and response. We'll have const URL equals request.url. And if the URL is /hello, we'll do say hello controller. And if case /goodbye, we'll give it the say goodbye controller, then break. And by default, we'll say will be fallback controller. And what we'll do now is that we'll go here and we'll server on request, we'll execute router of request and response. So here we wrote our own router. So Doa says you have a problem with JSON.stringify. Well, and here wants it will want a string actually. So that's why we stringify it, and it's also more performant because when we're sending it, it's better to send a string. And anyway, on the client, we'll be parsing the JSON anyway. But we can remove it if you want here, and you can remove it for the say goodbye controller. So now what if we go back, we will see we don't have to launch again because no daemon is handling it for us. And what we need to do now is that if I go to my browser, we will, if I go to hello, it will say hello, go digital. If I say goodbye, it will basically not do anything and it will crash because it says invalid argument type must be of type string or a buffer. And we send it a JSON. And that's why we stringify it, though. Is that clear? Why we do stringify?
Please, again.
Okay, so here you see with say hello, when we send a response, we do JSON.stringify because we want to turn this JSON into a string, basically. If we don't, like we did for the goodbye controller, it will crash because we can't send a JSON in the response. We need to send either a buffer of data, of bytes, or a string. That's all we can send. And if we want to send a JSON, we need to send a stringified JSON and say in the content type that it's basically a JSON. Otherwise, it will crash. It will not work like we just saw. We, like the error said, like the error is pretty clear. It says, hey, the chunk argument in response must be of type string or an instance of a buffer or your unsigned int8 array, basically bits. And we received an instance of object. So objects are not an acceptable argument type. Object is not an acceptable type for the argument chunk in response in HTTP. We can only send strings, buffers, and unsigned int arrays. And int8 arrays, basically bytes. That's all we can send. So that's why we need, for it to work, we need to stringify the JSON. We don't have a choice because it won't accept objects. Do you understand?
Yes.
Okay. So now it should work. If we send to localhost goodbye, we'll get goodbye. If we send localhost hello, we'll get hello. And if we send neither, we'll get an error. It will look for it. Should have already given us a response. Let's take a look. What's the issue here? URL, default, fallback. Oh, we forgot to do this. Oh, this is bad. Okay. So now we see if we go use neither /hello or /goodbye, it will tell us to please use hello or goodbye. Otherwise, it doesn't work if I send anything else. If I send anything, it will say, please use /hello or /goodbye. Exactly, Muhammad. Stringify works like parse, but the other way around. So we parse strings to turn them into objects, and we parse and we stringify objects to turn them into string. They are opposite. They're the same but opposite. One converts from string to object, and the other from object to string. So now we've written our first API using the HTTP default library.
Could we send HTML?
What? We can send HTML as a string. Yes, HTML is text, right? I'll show you. 1 second. Go, 1 second. Excuse me. Let's get back to the text editor. Okay. And we'll add a new controller, okay? We'll add a new controller. And basically we'll call it HTML or get HTML controller. What we'll do is that we'll change the content type to text HTML. This is another MIME type. And we'll send this. We'll send HTML. Head. Title.
But it's boring to send like that.
Yes, you can send it as a file though as well. We'll see that when we
include or require.
No, that's the thing. We can only send. We can't send it that way. We can send in other ways that we'll explore through Express. We want to send HTML though, but we can send it in this manner as well.
Can
but
send
maybe
HTML file.
Yes, we can send
response.
the whole file. Yes, we can as bytes. As you will see when we get to Express, because we will do that. So let's first declare this in our router and see if it works. Case HTML get HTML controller. Let's format this and let's try it out. HTML. See, we got our HTML, right? Hello world. We can have another one being H2. Go digital is learning Node.js. And we can have whatever we want there. We can call it back and Go Digital is learning Node.js. So there we're returning HTML. We're changing the MIME type, the content type. If we want to send it through a file, it might be more complicated. As we go forward with more complex use cases, this might get more complicated. As you can see, the routing is not easy neither. And that's why we're going to use Express, actually. Express is going to facilitate a lot of what you see here. All right? So maybe let's get, let's introduce Express quickly. What will probably go through the details of Express next week. I don't think we'll have time to explore everything into details with Express, but we will definitely see how we can send HTML files instead of just text like we just did. Okay? Let's have this here. Let's rename it actually, call it HTTP server. Oh, and we'll change this here. We'll call it HTTP server. And let's comment it as well. Comment this. All right. This is our index.json. For now, our application does nothing. As you can see, we have shut down the HTTP server. So let's get back to our presentation. We saw how we could create our own HTTP server. But as I said, it might get more complex, and you'll see that it's not very organized, and it may be harder for us to build complex projects with only this library. And that's what Express is for. So what is the Express framework? So Express is a Node.js framework, and it's actually the most popular Node.js framework as of now. It is the most starred on NPM. So the particularity of Express compared to other frameworks in other languages, for example, like Symfony and Laravel for PHP, like Spring Boot for Java, or Core for .NET, it has minimum functionality of its own. It doesn't do much. All Express does is handle two things: middlewares and routing. That's it. So what Express does is it will basically handle through middlewares the object request, with the object that the request object, the request, and the response object response that we just saw. So we saw right now when we were trying to build our own HTTP server with Node.js without Express, we saw that basically we ended up writing a lot of functions that take request and response as parameters, a lot of them, right? In Express, these functions that handle requests and responses are called middleware. So what Express does is handle all these functions that use request and response as middleware. And what it does is it will send your request and response from middleware to middleware to middleware to middleware until you're ready to send the response back to a user. Anything else you might want from Express, for example, if you want to parse automatically JSONs, you'll need to add another library called body parser. If you want to add any functionality to the framework, since basically it's really small, you could say it's a library, not even a framework, you will need other libraries that will come and plug into Express that we call Express plugins. So we need different plugins for different tasks. We'll actually, next week, we'll go through a bit of basically common libraries and plugins we can use with Express. So let's try to create our first Express server. Let's ditch our HTTP server We won't using that. We won't be using that, and we'll create a new one called express.js, and this is going to replace our HTTP server. We're not going to use this anymore. I will keep it in the project just so you can read the code and review it. Excuse me. But otherwise, actually, I'm going to delete these that you created earlier with the files. Let's delete these. Let's move them to trash. So we'll go and create Express, but first we need to download Express into our app. So first thing to do is actually we're going to go back to our terminal and shut NoDaemon. And we're going to install Express, which will make our life easier when it comes to managing a real life project. So we have Express into our app. Let's run NoDaemon again. Let's go and npm run dev and have NoDaemon starting. So now what we'll need to do is that one second, my computer is slowing down a bit. Okay. Okay. The first thing we'll need to do is we'll go and require Express here. So we'll go and have Express equal require Express. That's the easy part. We will then have a new app we'll call app, and it's basically Express. We're going to execute Express. That's about it. And well, what we will do is that we will still add a few plugins that are by default. We'll go and do app.use. Every time we want to add a plugin or a middleware, plugin JSON middleware, we'll have to add it here. For example, we can add here express.json. That's basically adding the JSON middleware. What else can we add? We can add another middleware for URL encoded parameters, like we saw before with the get request. So we can have here express.url encoded, and we'll add to it a parameter here that is extended true. So now we've created an app. We've added a few middleware. What we can do now is basically start using, start our server. So how we'll do that is basically we'll create a server. So we'll do const server add app.listen, and which port should we give it? We give it we'll give it on again the port 8080, and we'll have a function running when the server is started. So we'll have a text here saying so.log server is starting, is online on port 8080. Okay, actually let's add here port 8080. It's better to do it here like this, and then here we'll just do port. Server is online, and basically that is it. If we want to close the server, we can of course close the server like this. We could close the server with server dot close. For example, if you wanted to force the server to close, but of course we don't want that. So let's do this like this, and we go into our index, and we will require express dot slash express, the express file that we just wrote. And that should get us running. I will explain the use of middleware in a second when we write our own middleware. So now you'll see that it says server is online on port 8080. As for middlewares, here's what they do. Like I explained when we were going through the middleware DOA, middlewares are functions that take request and response as parameters. What does it mean? That means that basically we can write our own middleware by going to express here, and we could have app.use any function we want that takes request and response. And we could have res.send hello, or console.log my middleware is running. And if I go and basically and if I go to my browser now, where is my browser? If I go to my browser and my server is running, and I go to localhost 8080, you'll see that I get hello. And you'll see that in my console, I will find the console.log. If I go to my console, you see my middleware is running. So basically, app.use takes, these are functions that are written by Express, which basically do stuff to the request. For example, here, express.json, what it does is that it parses all JSON that it finds in the request. Express.url encoded, basically what it does is that it will change everything in the request and add the URL encoded in a JSON, in an object. So you don't have to do it yourself. How that works is the same here. Let's say, for example, let's say I wanted to have here, okay, request dot, well, let's say here, let's say we have an input, okay? Input equals hello. I can have next. There is a function here that we can add as next. And we are going to add next input plus go digital. And then what we can have is that we can have another middleware after it. We can have here, excuse me, rec dot input equals, I'm sorry, rec dot message or input or whatever, msg equal hello go digital. This is maybe easier to understand this way. And basically, then we're going to have next. And here, if we go in console.log or have a response.send request.msg. If we do that and go here, you'll see it says hello go digital. What that does is that how these middleware work is exactly like this, is that basically they inject something in your request and call next, which means it will call the next middleware in the series. I know this may be a bit complex, but that's how they work. Basically, middlewares are all functions that must take request and response, and potentially, optionally, can take next. And what they do is that basically they can either return a response, like what I did here, or inject something into the request and pass it to the next middleware. So the middlewares that I used here are basically work exactly the same way, but all they do is they're going to take stringified JSON, for example, here. This will parse stringified JSON and inject it into request.body. Okay? This is what it does. Oops. Let's add comments so you might understand it. And this reads parameters that are URL encoded. For example, first name equal Hazem and last name equal here, and inject it into rec.params as an object. So you don't have to do it yourself. Basically, they will do it, injected like we injected right now, and you will have it ready in your request when you need it. Exactly, Doa. So express.json is just a function that will do this, and basically will, if we send any request, it will look for the for stringified JSON, parse it, and inject it into request.body as an object. And URL encoded does the same thing, but for URL encoded data. So you don't have to struggle yourself at looking at the URL, looking at for stringified JSON, and basically parsing it yourself. It does all that for you as a middleware and injects it into your request. Is that a bit clearer? I know it may be a bit of a complex subject to grasp, but is it clear? At least a bit.
A little.
I mean, you probably need to write, maybe read into it more to maybe understand it better. Because I understand it may be a bit complex to understand how it works, but keep in mind this is like a middleware, and this does literally the same thing. Same thing, we're injecting into the request. You can see them as functions that inject data into your request, and they facilitate your life, that make it easier for you. So you don't have to parse your JSON alone. You don't have to get your URL encoded data alone. It will add a lot of stuff. There are a lot of middleware that you can find that make your life easier. And we'll talk about them a bit next week. But in the meantime, I encourage you to review. I mean, we reached the end of our session today. We're actually a bit late even. So I encourage you to review. I will share with you the presentation and the code. I encourage you to review what we saw today and read documentation as well. So you might grasp these subjects better, because definitely next week we'll be going deeper. We'll be creating an API. We'll start learning about MongoDB. We'll start reading from a database, writing to a database, and it's going to be way more complex starting next week. So I really encourage you to, review what we did and read into it a bit by yourself as well in the following week. So, and does anyone have any questions before we leave and end this today's session? Okay, no questions? Good. So I guess we will leave it at that and end today's session here. Again, please review it. .send. Oh, okay. We have a question, it seems. .send basically sends a response to the browser that made the request or the client that made the request. It's like we did here. It works like this. It works like res end in the HTTP library. Even though it has a few bit ways we can send as well. But it works like that. It just sends data. It sends data back. Thank you everyone for attending today. I hope the session was interesting and that you got useful information from it. Thank you for your time and have a great day. Goodbye. See you tomorrow.